Okay, yeah, all right. So it's recording, and I bet the resolution is much better. At least I think it must have picked a resolution algorithmically.
Yeah, I think it did.
Yeah, I think with the other software, they had some fixed resolutions that they had you pick one of them, when it should just be possible to pick the ideal resolution algorithmically. Okay, is this much better in video?
Much better, much better.
Yeah. Okay.
It's better, way better.
Wow. Okay. So let's use Zoom tentatively for now until I figure out the YouTube thing, and then Zoom also is my second preference, not my first preference, because even though it records it, I think the recording is not available so easily to the other students. So I have to go to the public. So I have to figure out how to get the recording just be available to everyone. That way you can just watch it anywhere you want, when you're commuting or driving, not driving at the wheel, but in the passenger seat, or driving at the wheel in a Tesla. Yeah. All right, okay. So I think this is it. This is what we'll do for today until I get there. All right. So you guys should just feel free now up here. There.
On the Zoom, I think there's several of us that need to be admitted
Oh,
into the room.
Thank you so much. Yeah, 10 in meeting, admit all. All right, are you guys? Forrest. I'm gonna click admit all again after about 2 minutes, okay? Because people are. Why is there an option to automatically add people?
I don't think so, since it's locked.
I think you have to add people as they try.
I see. Okay, all right. Well, I'll come back to this every few minutes. And all right, Gohan, I think Go emailed me just a while ago saying, "Where the hell is this conference link? I can't find it." Okay, you guys are all in here. This might be it. All right, I will try. Oh, okay. I got white lights. This light might actually work because it's much brighter. Let me see if I can point it at my. Oh, but it's going to shine into my face.
Dude, what the heck? You didn't even finish your breakfast or anything.
Well, okay, maybe here. Well, I'll work on, after today's class, I'll work on the, the setup and the configuration issues. But at least I got some information now as to what works well and, in terms of collaboration. Okay. So, anyway, so this is where most of our classes are going to take place. This is basically my home, and at some point I can, later on in the quarter, maybe I can give you a virtual tour or something. But for now, this is where it's going to happen. I will try and set up a whiteboard, not a whiteboard, some kind of something. Oh, actually, I'll get the iPad and share the iPad screen as one of the screens, so I can actually write on it, and then you can see it. Maybe that's a better idea. All right. So if you have not taken a class from me before, is everybody here? Let me admit more students. Okay. So there's how many? I got 34 students, 36 in the meeting. Okay, 37. So people are still joining. Looks like. Well, let's give it a few more minutes. Okay, well, guys, you take a break for about 5 minutes because people are joining, and then we'll resume in 5 minutes, okay? And anybody who's not here in 5 minutes, they can just catch up by looking at the video later on. And in those 5 minutes, I just want to think a little bit about some lighting options here, okay? So you're not going to listen, you're not going to hear me or anything for the next 5 minutes. All right? Okay. Alexa, set a timer for 5 minutes.
5 minutes, starting now.
Oh, this. The resolution is, I don't know. Is it because of my Comcast? I can't, which network am I connected to? Okay. Does Zoom have an option to fiddle with the resolution, transmission resolution, or does it pick it automatically? Yeah, I think it just picks it automatically, depending on what it can do. Oh, video settings, let me see.
Yeah.
So enable HD. All right, so let's say if I do that. Okay. Is there a difference? Do you guys see a difference if the HD is enabled? Well, it's not making a huge difference here. I can take the screen that you guys are seeing. Yeah. All right. Okay. Well, we still got a few more minutes before we start. Admit all. So what I want to do today is basically talk about introductory stuff. And if you have any questions about the way the class operates, facilities available at Foothill, via Canvas, outside of Canvas, tutorials, all those things. Right? You have a bunch of questions, you feel free to ask, and I'll answer those questions. I'll also go over standard bunch of policies, like no smoking in class, which I don't know if it applies anymore, but still, it's backward, right? Yeah, be good to others, be kind to others. No snide remarks, no meanness, stuff. No use of profane language, because lots of people are offended by it. Well, you don't have to care shit about it, but actually, no, that's not true, right? But you got to try and be as helpful as possible to other people. Because we think back, and many times you'll notice this when you go on to 2C or 2B or something. Some of these concepts that you're learning today, for some of the beginners, right? So some of these concepts will be so second nature to you that you would be annoyed, really. I have people who are annoyed by others coming into, others asking what they think are basic questions. And, but then what happens is that because you're learning so fast, I think this is my hypothesis anyway, since you're learning so fast, a lot of stuff that you learn now will be relegated to your subconscious. That's your second nature, right? So it becomes your second nature. And then, strangely enough, many of us just forget that we learned it explicitly, right? So we forget the class, forget that. In fact, no, we remember that we learned it, but I think we forget the mental struggles that we went through in the process of learning it. And it's especially true, I've found, of people who are basically spoon-fed information, or just given information. So suppose you say, I don't know how to do floating point numbers using this, right? And then instead of forcing you, sometimes against your will, right? To try out these things, right? And then you get frustrated saying it doesn't work, check it out. And, two people do the same thing, like I think it's Andrew and Giorgio, maybe. They collaborated online on Reddit, and they calculate some numbers, and they match it up, and that way you get confirmation that what you're doing is correct. Yes. But in the process of doing that, you get blocked and frustrated. Alexa, stop the timer. So, and you get frustrated, and then at that point, lots of people give up. But sometimes what happens is that if I personally, as your teacher, if I haven't felt your frustration when I was learning the same concept, yeah. So you're trying to learn a concept and you're frustrated. I did learn it a long time ago when I was a student, just like you. I learned it, and I was frustrated too. And the thing is, I might have forgotten the frustration, but I might have learned it. Or even worse, I might have been spoon-fed the information so that someone, well-meaning individual, right? So maybe they don't intend to do that, but they just gave it to me. Saying, oh, poor old Anand, he's struggling with this problem. I'll just give him this. Right? So someone gave it to me, and then my struggle is gone, my frustration is gone. And then what happens is that 10 years down the line, when someone else has the same frustration, and you want to try and teach them how to overcome that frustration, you've forgotten what that frustration was like. In fact, you never felt it because someone just gave it to you. Yes? So, and so you're not able to help them. And fortunately, in my case, I think I remember a great deal of the frustration, right? So every little thing, I have been given many times, corner cases and loops, and even data representation issues, right? So even when you're programming, hardcore programming, C++, doing all that stuff, sometimes you're dealing with data representation, fundamental data representation issues, right? You'll see that, if you go onto the Tue Sep subreddit, and you'll see a lot of people working on some advanced algorithms with graphs and trees and so on. And they're getting bitten by a very simple bug, which is very common. And that is a result of assuming that a number is always positive. Right? But sometimes you can choose a data type for a number that is, only positive. It's called an unsigned integer. But if you ended up using a signed integer instead of an unsigned integer, which is probably a typo, you could have just typed UN accidentally, then your program crashes. And it's all because of the data representation issue. These unsigned integers will roll over when it gets to the maximum values, the signed integers, right? When it gets to the maximum possible value, it will roll over and start at the minimum possible value. This is negative, it becomes negative all of a sudden. And that causes your program to crash and all kinds of crazy things happen, right? So that's why the foundations are so, Jason is here, let me admit him. Okay, I believe that everybody is in class and I don't have anybody in the waiting room, yeah? Okay, there's still a lot of interest around creating, hi all, it seems, well, Andy sent a message to everyone. Hey, Andy, you can actually just speak it because your message is scrolling so fast that it's hard to read it, I think.
Oh, can you hear me?
Yeah, I can hear you.
Okay, cool. So I just created a workspace on Slack for us to kind of collaborate on questing and general questions.
Great.
Hey,
Andy,
you guys want to use it?
Andy or
What's
Andy? That? Yeah. Does Slack let you share videos?
It does. You can share links to videos, and you can share
live streaming. Can you do live streaming on Slack?
No, you can't. That needs to be on Zoom.
Okay. Also, as far as the discussion goes, if you put it on Slack, I think a bunch of students might actually miss it. Because the more places you have to go to, the more confusion there is, right? Oh, yeah, I just realized I'm getting clipped on your video, right? I got a screen here. Okay. Talking about, yeah. There's more places you have to go to, more likely you'll get lost. and or not go to all the places, right? How many times have you gone to Disneyland and come out at the end of the day having not seen all the rides? Yeah, so like that, I would prefer. All the Slack is absolutely fantastic. I would prefer if you keep the discussions on Reddit or even Canvas, but Canvas not. I don't like Canvas for the reason that it's very hard to persist these discussions into the future, because as you will notice when you start doing your programming class, you will derive an astonishing amount of useful information and help from people, students just like you, who have started at the Tiger and gone all the way. And along the way, they've been making comments and observations and messages, posting useful messages, and you can, it's available to you, right? So you can go, 10 years from now, hopefully, if the question is still running, people can still go and look at your posts and say, hey, you know, back in 2020, and some guy called Andy posted a cool way to not hit that button, right? So the information and the knowledge that you create will be persisted into the future. It will be in Slack too, but there's no link to it, right? It's like a dangling pointer. It's gone somewhere. So try and keep it here. But for today's class, I think Slack is perfectly fine. And if you have any ideas on how we can completely integrate Slack into a class so that it's not lost or anything, let me know and we'll take a look at that.
I agree. I just want to say, I think that Reddit is great for like the really important questions, questions that not something like how do I access this quest? You know, there's just like Slack is more for like instant messaging and getting really quick answers as opposed to, you know, posting tech resources, you know, that should be on Reddit.
Okay, let's do it. Let's do it that way. And just remember to keep looking at that, you know, that channel on Slack channel. I have to as well, but I might forget from time to time. All right, great. You just have to remind me. What else? This is actually getting in my eye. I'm going to switch it off. I don't think it's making a huge difference. So I'm going to switch off this really bright light. Okay. Now we're all back. What time is it now? It's 8:45. All right, we've got an hour and a quarter for today, and we'll use that to talk about data representation, and also, you know, in this particular class and how my classes in general would look. So if you've never taken a class from me before, you have to remember that I typically tend to not help you debug your code or even offer what is generally considered programming help. Okay, so your program doesn't work, it's crashing, and you say, hey, can you take a look at this and let me know what's going on? No, and because you're learning, here's my recommendation. You don't have to follow this, but if you don't follow it, I think there's a very good chance that you may not do as well in programming in general. Okay? So never ask anyone to debug your code for you. And I think that is the greatest lesson I have learned as a programmer. Later on, when you're really comfortable with programming and you just have the finished product in your mind, because that's how it is, right? Because programming is not the end. Programming is a means. And I think that is the thing that people have to understand. Many students, especially in the Bay Area, in Silicon Valley here, right? They come around here and they look at all these big companies, Microsoft and Google and Netflix, and all these people around here, they're doing programming as lucrative and they're getting six-figure salaries. They say, oh, well, I want to be a programmer too, right? So they try and learn programming because they want to be a programmer. But that is the totally wrong thing to be learning programming for. You don't want to learn programming to be a programmer, right? You want, so, right? Because, you know, take English or Chinese or a human language, for example, right? So suppose, you know, a child, and you're teaching a child to speak English. And you don't teach them English just so they can speak in English. The goal of learning a language is to be able to communicate. Yeah? That's why when we talk, we not only use pure English, but we also use gestures, eye movements, especially teenagers, right? And all these things come together. And so the language that we use is just a means for us to communicate what's in our heads, right? Definitely not high fidelity, because what's in our heads is always, 100% of the time, different from what I describe to you. And so there's no way, unless you took a nano, subatomic, print of my brain and installed it in yours, then you'd be pretty much the same as me, right? So there's no way I can communicate exactly what's in my head, no matter how picturesque a scene is, right? So even if it's beautiful, and even if you're standing right next to me, you know that. So you can't have the exact same experience. So I just use language in a way that, and you too, right, everybody, in a way that we hope will communicate what's in our heads with as high a fidelity as we believe that it can. And so programming is like that. So if you want to learn C++ because it's just another jewel in your crown, right? Or if you want to go around saying, hey, I know C++, I can program in C++, yeah, well, okay, so what? There's a million other people who can do that too, and you're just going to be one of them. And so, because that's a wrong reason to be learning C++. The real reason to be learning C++, any language for that matter, really. That's why I say, don't learn C++, don't learn Java, don't learn Python, but learn computer science, right? So you learn computer science, then you can, it doesn't matter what language, because you know what you want to do. And it's the same message that I keep repeating in 100 different ways in all of my classes, CS2A, CS2B, CS2C. Where CS2C, I say the same thing in terms of graphs, because they're working on graph algorithms and it's searching from here to A to B. How do I get from A to B, right? So when you're doing something, what's the most important thing to have in your mind as you set out to do anything at all is to know where you're going. Right? You need to know. So I need to go to San Francisco. Yeah, okay. If I know that I need to go to San Francisco, then I can pick my route accordingly. Right? If there's a big accident on 101, or there's some route is blocked off, I can choose a different route, and then I can go. But if I don't know where I'm going, and I'm just gonna go where the streets dictate, and my intuition tells me, oh, that's interesting. Probably leads to San Francisco. I'm basically stuck. If something is blocked, I'm basically blocked for good there. Or, I feel extreme disappointment and shit like that. I don't want to. So what we want to do is really learn C++ as just a means to express the ideas in your head. So for that matter, I want you to feel the frustrations. I want you to struggle. Just like me, not saying, oh, I had a tough time, I struggled, so everybody has to struggle. No, not like that, okay? I wouldn't say that if I struggled and I didn't come out of it. So if I struggled and I'm still struggling, then I wouldn't say you guys should also struggle, you guys should also suffer, you guys should also get really frustrated and start thinking that you're not computer science material and you can't learn computer science. And if I didn't have a chance to get over that bump, it would be cruel of me, right? It's pointless to me. What's it going to do to me, right? To tell you to struggle, but if I haven't figured out a way to get out of the struggle, right? Now, thankfully, because I'm so much older than you guys, I've had a chance to live the life and face all these different struggles, and then fortunately, maybe low odds, I emerged on the other side, okay? So now I know that the struggle was actually worth it, right? If I didn't come out on the other side, I would never know if the struggle was worth it. And then I can't tell you to struggle. Because, you tell me, why the fuck did I struggle? And I say, I don't know, man, you gotta struggle. That's not a good answer, right? So, but now I can tell you with confidence, right? So it's worth struggling, get out on the other side, because there's a whole new world out there. There's a whole new world. Once you know how to do something, so once you know English well enough to start writing a story, then you're not thinking about English anymore, right? You're thinking about the story, right? So what is Jon Snow going to do next next month, something like that. So you're thinking about the story, and then the language just becomes a means, and that's where you need to be, and you will get there. believe it or not. So, and that's the other incredible thing. And unfortunately, I don't know how you can preserve this memory of yours. Maybe make a note, make a mirror. You know, not with what's they used to call it a mirror in my daughter's school a long time ago, right? So make a snapshot of how you're feeling about computer science. You don't have to share it, right? So make it in your own Google document or somewhere, store it. Just pour your thoughts into it. Saying, oh, you know, I don't know. Everything is so, you know, Greek and Latin to me, unless you're actually a Greek person, right? So, so you can say, and then at the end of this quarter, go back and look at that and see how your own attitude towards computer science has changed, and you'll be like totally surprised, blown away. Because I know a lot of people who thought they were not computer science material, right? Especially after my first 5 classes, right? After the first 5 classes, things become really, really challenging. Okay, even for 2A, the first few classes, the first few labs in the class, you know, set up to be easy so you draw you in and draw you in. But once you're all in, then I'll go and check the door and lock it. Okay, so, but once you're in, I know a bunch of people who were basically driven all the way to the edge, and they were close to giving up. But they said, no, I think I should go major in something else, because in addition to computer science, I've also been doing anti-ceramics classes, or, you know, something in anthropology. I don't know. So English. So they say, you know, that's my major. This is just going to be a side interest, and so I'll come back to it later. But I say, no, just give it a shot, okay? It's only CS2A. What the hell? You know, CS2A is going to be reasonably easy A. It's not as easy as maybe some other classes, but compared to 2B and 2C, it's an easy A. And, you know, there's so many people who help you. All of your classmates. We've got fantastic tutors in the STEM Center. It's all paid for and free. I think Lane Johnson especially holds these tutorial sessions, especially focused on only the classes, right? In addition to other things, right? He also does regular tutoring. So we have absolutely amazing people in the department who are genuinely willing to share their expertise with you.
Hey, Anand.
Yeah, so
It sounds like your second computer is still giving some feedback audio.
Oh, is it?
Yeah.
This thing here, you see if I can search my I could just mute my Mac itself. All right, so it's not mine. Are you still hearing that feedback, Nick? Hey, Nick?
Yes.
You're still hearing that feedback?
It looks like, I mean, everyone.
Okay, I think it's someone else. What I'm going to do is basically mute everyone except me. And I think that Zoom has this option to audio settings, is it? How do I mute all the participants? Oh, mute all. There you go. Okay. Well, everybody's muted, and I'm still hearing that.
We're still hearing it.
Spurts of white noise, right?
Yeah.
Yeah.
Where's it coming from? So maybe it's not feedback. Oh, it's gone. It's gone now. Is it gone? For you guys?
Yeah, I don't think so.
Oh, don't think so? You still hear it?
No, it's definitely gone.
Yeah, okay. So you know what I think? The audio is probably lagging, or you know, the entire feed is probably lagging, is it? Because I muted it and then it took a few seconds.
You mean after you muted it all?
Yeah, now it's gone, but I was continuing to hear that sound for a little while after I muted.
Thank you.
Yeah. Anyway, so we'll go with that. And oh, by the way, I also got the last year around this time, I was teaching a cloud class with AWS Cloud, and Amazon sent me a Deep Lens you know, for free. They just sent it to me saying, "Oh, try it out." And you know, where is it? So yeah, it's deep ones, and that does have streaming capabilities. So, but I tried to set this up yesterday, and unfortunately, this was last year, but my environment was not as conducive to set up the streaming cam last year. So I held on to it. It was in the garage until yesterday, and then so I set it up. But I think because it's a whole year, something must have changed. Well, it couldn't possibly, unless it updated the firmware when I connected it. Because I think what happens is that when I power it up, in order to sync up with my Wi-Fi at home, you would, this runs a web server and has a Wi-Fi signal. You connect to the web server. You connect to this Wi-Fi and then connect to this web server, and there you can configure the internals. So, but it didn't work. So I've got some open questions to Amazon. If it gets fixed, then we'll actually have a much better streaming experience, I suspect, because this camera is much better quality. And let's see how it works, okay? And then I can also program it. I can program this camera to do some, you know, intelligent things, right? Like, I don't know, we'll figure it out. It can do object recognition and face recognition, and it can start streaming when I'm within the frame, or you know, when my head is cut off, it can tell me, hey, you know, move back a little bit. It's like that. So we can do all those cool things once we get rolling. Okay, so back to the style of this class. Okay, no spoon feeding, no help. You guys are going to help each other, but I'm going to be watching all the time. 100% of your posts on Reddit, if it comes in front of my eyes, right? So that's one of the issues with Reddit that I don't like is, is that it's not possible to subscribe or auto-subscribe to all the threads, so you don't get notified. So sometimes when you have a thread, it's the same thing in Canada, and I think Canada's also has that issue, right? So if you are posting in a thread that's already like in position 8 or 9, I don't get notified, and then might be a very rich conversation happen in one of those threads, and I totally don't get it, right? Unless someone tags me in the post, then I get a notification, then I can read it. And I say this because, you know, over the summer, I was trying to browse the Reddit forums to see, hey, you know, quarter is going to start in a few weeks. I better look at what students said last quarter to see if, you know, I need to make any fine-tuning adjustments to this class. And then I saw that there was a whole bunch of Reddit threads where very interesting and rich discussions had happened, and I didn't know, right? Because I only look at the ones that I'm tagged in, or the first 5 or 6 posts in Reddit every morning. So if you're in there, I will absolutely see your post, and I'll reply to it. Maybe reply to it, but I will know that you posted. And personal help with stuff. Mostly, I will try and enter that mode of helping you with specific things. Not debugging your code, but helping you figure out, or, you know, pointing you in the right direction, closer to the free state, right? Probably 2 weeks before the free state. When then I'll look at outstanding questions and say, hey, try this instead, you know, try that or something. Okay? So until then, you got to keep at it. Now, the important thing to keep in mind is that if you run into a bottleneck and you can't get past it, you cannot assume that I'm going to let it lie and come back to it, you know, 2 weeks before the class because I can ask on and then he'll help me. Don't do that. Because, well, first of all, if you do that, then you won't be able to progress past that class, right? And then you'll only have limited days to finish all the classes before the final free state. So keep at it, right? And then if you feel frustrated, it is perfectly natural. I think that is it. I think that's it, right? When people feel frustrated in C++ programming, I think they mostly end up feeling that it is a singular frustration that nobody else feels. And they think that, oh my gosh, this is totally awful and everybody else is just swimming along and I'm having a hard time, so maybe CS is not for me. No, that's not right. Because how do you know? How do you know everybody else is? So I think someone told me the story in a previous class about ducks. It's called the duck syndrome. And apparently it's rife in the San Francisco Bay Area. Well, fortunately not in my classes, but it used to be, in my class too, until about 2 years ago, right? I've taught here for 4 years now, at least, 5 years now at Foothill, right? So until about a couple of years ago, even in my classes, we had the duck feet syndrome, is it? Or I don't know if anybody else knows it. So there's a bunch of ducks floating around on a lake, or swimming in a lake, and they're just going so, just zipping by on the surface of the water. And the water, you don't even see a ripple. It's as though they're just, floating by and they're not doing anything at all. But if you look at the underwater camera footage, you'll see that their legs are, flopping quite furiously. They're doing a lot of work in moving, and they're moving so carefully that they don't, cause these ripples. And the unfortunate side effect is that, if there's a duck on the shore, looking at these ducks, it's so easy to skim the water. I'm going to get in the water and do it too. But then it finds that it can't do it because it has to do a lot of work. Because from outside it looks very easy, and that's because these ducks, it's not their intent to make it look easy, right? Or maybe, it's they put in a lot of work, but they don't show it. And the unfortunate consequence is that a lot of students who do put in a lot of work, they're conscious of a lot of work, of the work they put in. Look at the other students and say, oh my gosh, I can't do it as easily as they do. So maybe I should be doing something else in my life. That's not right, because anybody who does, well in this class is probably putting in a lot of work, either now or they have put in an equal amount of work before they started this course, right? Who knows when? Maybe they've been working in industry, out there. Maybe they're working at some big company, programming at Microsoft or Google for 5 years, 10 years, so for them it's so easy. They can do it like that, and they do it in their sleep. But when they first program, they did go through the frustrations and the struggles, and maybe they've forgotten, maybe they haven't, but that's basically what happened, right? So don't feel discouraged or turned off, because there is this wealth of information, this wealth of beauty. There's a wealth of beauty in computer science that I just can't wait for you guys to just uncover and enjoy, so we can all enjoy it together. And I think that's the goal, right? That's the goal of anything that we humans do. I think, we find something that is beautiful and fun and enjoyable. You just enjoy it as much as you can, but when you reach the limit, right? There's no more enjoyment you can get out of it by enjoying it yourself. Then you say, all right, now I want other people to enjoy it also, so that the joint enjoyment is much better. And you find that, you can enjoy it through someone else's eyes, almost as well as you can enjoy, as well as you enjoyed it yourself. So that's one of the reasons why many people are teachers too, right? Because, computer science is so beautiful, science itself, right? Everything, knowledge. There's so many interesting, beautiful things that you can uncover about this world, right? And then you just marvel at it. You don't have to do anything. You just sit down, you think about these things, and you marvel. And it gives you hours of pleasure just thinking about these things. And then you say, well, you know what? It would be so much better if more people can enjoy the same thing. And then you say, I want to teach it. I want to teach this, how to make a pot, right? So, you go enroll in ceramics. Oh, unfortunately, you can't do ceramics now. I wonder how Andy is teaching his classes. Unfortunately, Andy's home got burnt, I think, in the fire. So, yeah, but you do you make something, and then you want to say, all right, now I want to show other people how to make the same thing, so that we can together make a bigger thing, or make small things, lots of it, and enjoy it. We want to have fun together. So that's a goal. The goal of this class, all of my classes, anything I teach, is designed so that we can have more fun together at the end, right? So when you've mastered stuff, we can get together and do interesting things, or you can get together and do interesting. You form groups, or join other people, meet up, and there's so many opportunities all over the world, not just in the Bay Area, right? Especially now that everything is online, remote places, some corner of sub-Saharan Africa where, it's hard to get internet signals. But sometimes you do get, through Facebook or Google efforts, beamed in from satellites or planes, anywhere in the world. If you're sitting down and, with an internet connection, you should be able to enjoy the pleasures of programming. Yeah, and back in the day when I learned to program, you had to buy compilers. You had to buy everything. And yeah, I remember, yeah. Anyway, so you have to buy computers, and compilers used to cost a lot of money. And Microsoft C, when I started programming, this was back in India. It was quite expensive. I couldn't get it. And so one person that in our company had a personal copy that was gifted to him by a relative. And so we would all write our code on paper. And then when we had a chance, when he brought his computer in, we'd type it in and give it a go and see how it went. It wasn't for long. And soon after that, we had an opportunity to get compilers of our own. But for you, that's not an issue. Everything is free. Not even the hardware, right? You just go to a library. You can go to your city library and sit at a computer. And then the compiler is online. You shouldn't be using an online compiler all the time. Right? It gets cumbersome after a while. You can use Git to persist your code, and so many options. But don't always compile code past. I think quest number 3 is okay. After quest number 4, it gets really cumbersome. Maintaining your code online. So try and have a local environment to actively code. But the online compiler to get started, it's all free. Yeah, I'll show you, right? When we get to programming in a couple of classes, I'll show you how you can code. Hey, you know what? I think it's just a backlight. Okay. Maybe this will make it brighter. Well, it didn't help. Maybe it's the other side. Is that better? That's better, is it? Is it brighter?
It's much brighter right now.
Yeah, okay. So I think it was just a backlight and was compensating. All right. Okay. All right. Okay. So let's get back on track. Yeah. So as far as my class is concerned, so you guys know how it works, and continuation of that initial topic will pepper it through the class and through future classes too, because I don't remember everything that I need to say about the logistics. Data representation. All right, so let's start at the beginning. So computing is all about processing information. That's all it is, right? So even, we're not even talking about these computers. Even in your head, right? The computer inside of your head, the neural network that's inside your brain. Even that is only concerned with processing information. Some of the processing might result in epiphenomena maybe, or, I don't know. So there's this whole, we won't go into the philosophical side of things, but, it's just information processing. And so if you want to master computer science, all you need to do is just master, information itself. What is information? How do you store information? How do you process information? Yeah, so that's really what it is. That's the basic foundation of computer science. So, and there is this little story that I recounted in module 0, and this is quite a long time ago, maybe 10, 15 years ago. That was this party, and one person at dinner, I think, and we were talking about languages, and once one of the people said, something about, yeah. I think she said we should. It'll be so much easier if we use English, the script, the Roman script, right? A, B, C, the English script to write all the languages in the world, right? Every language in the world written using English script, because, well, you know, she had a reason for that. And she said the reason for that is because she wants to learn all these other languages. She wants to learn as many languages as possible, but you know, there is this bottleneck that she has to learn the script first and then how to speak it. Whereas if all of the languages were coded in just one you know, script, then you at least got past that first block. So you know how to read and write, and you know how to speak it also. The only thing now you need to do is attach the semantics to the different tokens, right? And the grammar, which you have to do anyway. You have to learn the grammar and the semantics anyway, but now we just removed one part of it. So that was a rationale, and it was actually a valid and a good rationale. Would you agree? Yeah? Okay, all right, nobody's agreeing. Is that right? Can you guys hear me?
Yeah, it is right.
Yes. Okay, all right. So it's just that you don't agree. Okay, anyway, so, but someone else said that's not possible. It's not possible because they said, well, in my language, we have these tones, right? So in Chinese, or Mandarin, you have 7 tones. And then the same word spoken with, you know, these different tones have different meaning. This is different semantic content. They're minimal pairs, right? So a minimal pair is basically 2 words that look exactly the same, but they have completely different meanings. So you can look at, so that's the essence of science, isn't it? That's how we bring science into everything. Science is essentially, if you're a good scientist, no matter what the field, whether it's computer science or anthropology or linguistics or chemistry or physics, all of science is basically revolves around your skill to identify minimal pairs. So what is a minimal pair? A minimal pair is, you know, two items that differ in exactly one thing. Yeah. So in fact, you know, I think that is the same reasoning that Leibniz is one of the inventors of calculus. I think he used the exact same reasoning to come up with a criterion for the identity of 2 objects. Right? You can say, you know, I can give you 2 pens and say, you know, are these the same pen or 2 different pens? Right? And then you can look at it, they're 2 different pens. Even though they look exactly the same, they're 2 different pens, right? So you'd say they're 2 different pens, but how can you tell they're 2 different pens? You need to have a formal, right? So you need like visual inspection or, you know, hearsay or authority. I can say they're 2 different pens. Those are not really. So how do you tell they're 2 different pens? How do you convince yourself in your head that they're 2 different pens? So you need to have a formal criterion. So, and you know, Leibniz was one of the people who formalized it. You know, this criterion has been around forever. He said, you know, 2 objects A and B, they're different if at least one of them has one property that, at least one property, right? So it has a property that the other one does not have. So then they're 2 different objects. So, you know, 2 pens, and, you know, they're exactly the same in every way. What's the difference between the 2? One of them is here, and the other one is here. This pen is not here. So this pen has a property that the other pen does not have. They're 2 different objects, right? So, because now, that means I have constructed a minimal pair. Now, why is this important? In science, we are always looking for minimal pairs everywhere, even linguistics, right? So how do you know if 2 words are actually different, or are they just, you know, spoken differently, different dialect? You find 2 words that are exactly the same, but they have 2 different meanings. They're different in one phone or one phoneme, right? So you can say that phoneme was actually, it's a contrasting pair. You can say that they're different. So likewise in science, it is the core of the scientific method, your ability to come up with these minimal pairs, because you want to create repeatable experiments in science, right? But what is it now? Alexa, what time is it? Alexa, what time is it? Oh, here it is.
The time is 9:18 a.m.
Yeah, okay. We got 45 minutes left, right? So you guys can remind me. And by the way, one of the things in my class, yeah, okay, this is very important. Hey, so someone remind me where to get back to, because, you know, we're talking about identity and minimal pairs, okay. So in my class, here's something that's very, very important. I might tell you things that are untrue and wrong, as well as things that are, you know, true and right. So, and you'll be totally surprised. And this guy's supposed to be a teacher, and he's telling us wrong things, right? This is false things, untrue things. Right? Obviously, I'm not going to tell you totally false, or not totally. I'm not going to tell you ruinously false things or false things that are going to be bad for you. No, I'm going to say things that facts, right? Facts that are probably untrue or true. And how do you know? How do you know if what I'm saying? And by the way, there will be a lot of digressions in my class, and so I might start talking about something, but it's all free form. Okay, it's all free form, and I might start. There's an interesting thread. I'm going to start talking about it, and maybe it's not even related to computer science. And start talking, and then at that time, but to make up for that, what we'll do is we'll have these free-form lectures. I can have as many of these lectures as possible. Right? I have a lot of free time, and maybe if you want to lecture in the evening sometime, I'm happy to do that. Often, not part of the foothill, but I'm happy to do these informal lectures. I can give you as much information as possible. But anyway, so where were we going with this? Yeah, so I might digress a lot, but if you feel that we're digressing too much, I might not know, because part of me is basically when I start talking, I just stop and I forget about what I'm doing because I'm just following a trail. At any time, I'm just following the most interesting trail in front of me, right? Well, not like totally, but we know where we're going. But we'll get back there eventually. But sometimes it's your responsibility not to respond. You got to remind me, okay? And don't feel shy. Don't feel shy, and don't text in the chat window saying, "Hey, Anand, get back on track." Okay? You should feel totally free to scream out through your audio. Everybody can listen. Hey, Anand, I'm not interested in all that shit. Talk about computer science. I'm happy to get back, and I thank you, right? So I would thank you for that because you gotta bring me in, pull me back because I'm going that way and that way and that way and that way. Keep pulling me back in. And then I'll be with you all the way to the end, well, even otherwise, but this way closer together, okay? So we'll do that, keep reminding me. So yeah, minimal pairs in science. Why is it so important? Because we're trying to create these repeatable experiments, and then you want to create, and then let's say you're doing something and it just doesn't, it manifests a certain behavior that you want to know why. Right? You want to know why. Let's say, in your garden, you want to know if ammonium sulfate is a good fertilizer or not. How do you tell, right? So we set up what is called a controlled experiment. Before you set up controls, it's not really hardcore science, right? It's just playing around. That's important. It's important to play around before you set up controls to just get a feel for everything. See how it happens. Hey, if I add ammonium sulfate, it actually grows faster, or something like that. But then you want to confirm that it actually works that way. So what you do is set up two identical environments, right? Two identical. They have to be as close to each other as possible. Same soil, same seed, as much as you can. And why does it need to be identical? It needs to be identical because only then you can add the ammonium sulfate to only one pot and not the other one. Then you can see the difference, right? If they're not identical and they both, one of them shoots up and the other one is stunted, you can't tell. You can't tell whether it's the ammonium sulfate or something else that made this one grow and that one not grow. So by making sure that they're identical except for that one thing, you have what is now called, what we call control over the experiment, okay? So you control the experiment does not control you. So that is called a controlled experiment, which you will be doing again and again, not just in your college career, not just in your life, not even in your career. You're going to be doing that all through your life. Until the day you die, you're going to be doing controlled experiments with people, with things out there. And that's how we do it, right? And that's why, and that is the scientific method, formalized in a proper way. Because, once you do a controlled experiment, then you can take that to the next level and say, okay, well, with ammonium sulfate, I have established that a plant grows much faster than one without it. Okay, you repeat it many times. Why do you need to repeat it? Because maybe there was an error. Maybe there was, atmospheric conditions. So you repeat it many times, swap the positions and all these things and take the average. So that why do you take the average? You take the average. So, all these things will come across. We'll talk about more and more as we dive deeper into this course, right? But the basic idea is to isolate. Now, even if you go to a doctor, that's what they do, right? So he or she will ask you many questions because they're trying to isolate the reason for your pain. And then once they find out, then they can treat it. And that's how it is. That's how in computer science we're going to do things. Because in your programs, what you'll find eventually is that, hey, my program just doesn't work. Okay, whereas that guy's program works. Or, her program, no problem at all. So how can you tell? So what you do, or you might have a program that worked, and then you made some changes, and then it didn't work all of a sudden. Okay, that happens 99% of the time. Many people will just post on the forums. You can search Reddit right now, right? And see that lots of people have posted saying, hey, this worked beautifully, but then I made that change for that new mini quest, and then my previous quest all broke. Right, in previous mini quest, now I'm getting 0 trophies instead of 15 trophies, something like that. And how do you get to the bottom of those things? And you get to the bottom of that by being a good scientist. Right? So that's how it is. By being a good scientist, looking at it with a scientific lens, a scientific perspective, which means that you're going to start creating minimal pairs in your program. What's a minimal pair in your program? The program that worked beautifully before and a program that didn't work. Okay? Now you're going to try and chop off everything that didn't work in your non-working program, right? And to match it up. So you're going to keep taking away things that from your program until the point where it starts working. Okay? Then it's identical to this other program that worked. Okay? And then you start adding stuff again, and at some point it'll break, right? Then you know that, okay, well, I've got it to a minimal pair. These two are perfect, exactly working per spec. But then there's one extra feature added to this, this program, breaks it. So now you know. Now you know why. So that's how you set up a minimal pair. Okay? So that's how you. Anyway, so coming all the way back to information representation, this person said, you can't represent Mandarin using English script, right? Even though pinyin, right? So you can because you can't do the tones, right? And there's African languages, right? And I think even East Asian languages, maybe, I don't know. Where you have clicks, right? You have clicks, clicks that you produce, right? Like that. They have semantic content, meaning that there is it's part of a word. It's not an onomatopoeia, right? But it's a word with a click at the beginning. Means something different from a word with a click at the end, right? So these things are. And so they say that person said, no, you can't use it. It's only got 26 letters, and my language has these sounds that you can't represent. But but that's not true, right? Because if you think about it, you only need 2 symbols to represent any language, right? Not only in the world, right? Any language, even of aliens who visit us in the distant future. Well, we may not be able to understand each other, but we can tell them that no matter what you speak, we have a system to encode it, right? So we can say we only need 2 states, 0 and 1, right? On and off. Those are the only 2 states you need in order to be able to represent any information you want. Right? It's pretty. We don't have a whiteboard yet. Well, we'll get a whiteboard or something equivalent to a whiteboard at some point in the next few lectures. But basically, when you have the ability to control the position of switches, then you can encode and transmit information, right? Because this is a story that I used to tell during my very early years at Foothill, 6 years ago maybe. Back when I was a student, I went to a college which was a residential college. And so when I needed to communicate with someone in a different hostel, we had to live in hostels, right? I had to communicate with someone in a different hostel just elsewhere instead of walking all the way over. And we didn't have phones, right? Today, you can just pick up your cell phone. But back, this was, back in the late 80s. And we didn't have phones. And even there was the landline. You'd have to go to the hostel's telephone room to make a call from there. So we figured out a way to communicate with each other by using our light switches, right? And so, if if the light switch goes on and off immediately. It's just like, just like Morse code, okay? I think we actually used Morse code because we were both enrolled at that time in radio or ham or something like that, some evening class, and we're trying to learn Morse code. And so we were communicating using Morse code. 2 different buildings far away from each other, but we could see the windows. I could see her window and she could see my window. We could communicate, right, with these lights on and off. And then the next day we would basically, first time we would confer and see, hey, this is the message I sent. Did you get that message? And we didn't actually see that. And so, and it's possible, right? Because now I can say, well, if I want to send you the letter A, right, I'm going to, but this agreement has got to be in place before. When 2 people start communicating, now it's the same. It's the same even now. We have an agreement in place. You and I have an agreement in place that I'm going to talk in English, yeah, and that you understand English. Yeah, that's one of the prerequisites of this course, right? So hopefully at some point we would have automatic translation, right? Even now we can actually do it, I think. But the recognition and translation combined have their era. Like, but sometime in the near future, we'd be able to have real-time translation of anyone's, talking, so that in Zoom or some app, you should be able to go and have a switch down, drop-down menu and say, I want to listen to this lecture in Arabic or, Swahili or something. You pick the language, and then, you hear me, even in my own voice, right? You can take the, my flame, you can extract all the essential information about my intonation and things like that. You can try and map it and apply as many of those characteristics as possible to the synthesized speech. So it actually sounds like me speaking in Swahili to you, right, in my language. So that should all be possible in just a few years. But until then, we have this agreement between you and me that, I'm going to speak in English and you have better understand English, which is kind of unfair, right? But, for now, we're going to live with that. So we have that agreement. But if you didn't understand English, and I talked in English, there's no way you're going to get any information from me. Yes? But there is a way. But there's, here's an interesting related thing, right? Suppose that I have a class of 1,000 students, and let's also take this analogy to the extreme and say each one of the 1,000 students speaks a different language, right? And they're all in this class, and I'm talking to all of you, right? Or maybe offline, right? Not synchronously, asynchronously. Now, in order for me to reach all of you, I would have to learn 1,000 different languages. Yes. So how can I solve that problem? What is one good way of solving that problem? Can anybody take a stab at that? So what is a good way of solving a problem where 2 people need to communicate, and person A may choose, right, completely arbitrarily, may choose any one of 1,000 languages to speak in, right? Person B also chooses arbitrarily, right, any one of 1,000 languages to listen in. Right? So we're going to make this fictitious assumption here that if you choose a language to listen in, you cannot understand any other language, okay? So even though you may know English and Swahili and all these other languages, once you say, for the duration of this lecture, for the next 2 hours, I'm going to listen in English, bam, just like, Neo in The Matrix, your Swahili module got unloaded, okay? And you got loaded with the English module. You only listen to English from that point on and understand English, right? So you got to choose your language. You got to choose. So what is a good way in which communication can happen effectively between 2 people that speak completely different languages? From a menu of many languages. What's a good way? So one way, obviously, is for me to learn 1,000 languages, and for you also to learn 1,000 languages. Yes. So that way, no matter what language I speak in, you're always able to listen to me in that language. That's a possibility, right? So where did that beat come from? But actually, maybe more people waiting to join. No, I had a beep. Never mind. Okay, so so it's not possible, right? It's possible, but it's what I would say is it's an exponentially hard problem. right? In fact, it's because if I need to learn 1,000 languages, you need to learn 1,000 languages. That's not a practical thing to do, right? So this is a real problem, believe it or not. It's a real problem that we, in the world of computer science, faced when we were, very early days, when, when computers were starting to communicate with each other, right? The very first internet transmission happened from, I think, UCLA to SRI in Menlo Park here, right, in the Bay Area. It was long before I worked there, but they very first internet transmission was the word login, right? It was a login prompt. I think it was a login prompt, okay? That UCLA, the computer at UCLA had to send to SRI, and someone from SRI had to log into the computer at UCLA. And I think the word LOG came through, and then the computer crashed. Okay, but it was successful. The first experiment was successful because data transmission actually did work. But when you're dealing with data transmission, you have exactly that issue, right? Because data transmission cannot work unless the receiver and the sender agree on the code, agree on the language in which they're going to talk to each other. But no sooner than we have discovered that two computers can now, using this network, talk to each other, immediately, just like everything else, you discover a product, a new kind of product, let's say touch screen, right? Everybody remembers, like 15, 20 years ago, maybe, the iPhone came out with a touch screen. But then now you look at it, everything around you is touch screen, right? I'm scared to touch the wall, right? But everything is touch screen. It's just everybody does it. And the problem with that is that as soon as some technology becomes popular and everybody adopts it, it's very, very important to have a standard. Because if you don't have a standard, everybody will be talking in their own language. Maybe someone could say my touch screen will respond to capacitive changes, right? Someone could say my pressure changes. Someone could say, touch screen, just other factors. And then maybe they'd say, this kind of pressure causes that behavior. And so they're not interoperable. And so in order for everybody to work together harmoniously, rather than, different directions, everybody agrees on the same standard. There's actually a story, this is an old story about a boat race, right? So two teams were participating in this boat race. They do this every year. They have the boat race, annual boat race every year. And Team A continuously lost to Team B. Every single year, Team B wins and Team A loses. And so the captain of Team A decided to hold a conference and say, all right, you guys go and figure out why Team B is always winning and why we're always losing, okay? And then, so they went and studied the way that two teams operate, and they came back with the results from the study and said, we found out why we're always losing and Team B is always winning is because in Team B, their boat has one person who's steering the boat, and then it has 10 people that are rowing the boat, okay? And so they're going faster. In our team, we have one person rowing the boat, and we have 10 people steering the boat, all right? So we're pretty much in the same place, so they said, okay, well, now it's fantastic, right? We found the reason why we're losing. Now go and try and find a fix to this problem, right? To try and figure out a way we can win the race. Now that we know why we're losing it, let's fix it. So next year we can, keep their royal ass, right? And win the race. And so we studied and we came back and we got the answer. We know how we can win, right? And he says, why do we win the race? And I said, oh yeah, okay, the guy who is steering the boat, he has to steer much harder, okay? So, but that's not the way to do it, right? So you need to have unified direction, and then, it will win. So, and the same with data communication. So if you and I agree on a unified way in which we can communicate, the communication works. And how did we get started on this track? We were talking about data. Data communication, right? So there's, and so no sooner than we had discovered that two computers can talk to each other, because there's always so many intelligent people. Really, they all said, I'm going to come up with a way in which two computers can talk to each other. different standard, different standard, different standard, different standard. So we had, you know, as an example, this is not the exact, just examples, right? So we had an Intel family, we had a Motorola family, we had an AMD family. So you have all these different sub-universes, right? Sub-universes, you can talk within each universe using their own language, which you can talk to other universes. Just like here, right? In the real world, you know, inside of America, we can talk to each other in English, but you can't go all of a sudden to some country you don't know the language of and start talking. You can't do that. So within each silo, you have perfect communication, but no, not so much between. So how do you solve that problem? And so one way is to say that all Americans should know every language on earth. You know, everybody in China should know every language on earth, so everybody can talk to each other. So or you can do it the Star Trek way, right? This is what is Star Trek, the blind guy who wears the thing. Is that it? Or something else? I don't know. It's such a long time since I watched Star Trek and all. So
I think you're talking about the universal translator.
Yeah. Oh, actually, it was not Star Trek. It was Hitchhiker's Guide, right? So it's something you put in your ear. It's called a babelfish. Babelfish. Yeah. So it's called a babelfish. You put it in your ear, and then from that point onwards, it doesn't matter who you're talking to, what language, anywhere in the universe, right? They can say anything, and you'll just hear it in English, okay? And then you can say anything. Well, actually, it's not. You don't have a babel mouth, right? You will hear, but you'll speak in English. Oh, they would have a babelfish in their ear. Okay, all right, good. So you can talk in your language. They can talk in their language. But for all intents and purposes, you never even notice the difference. You think that that alien with 15 heads and 20 arms is talking to you in English, but it's actually talking to you in alienese, right? And you have no idea what it is. You can't even see its mouth moving but this babelfish will translate for you. So that turns out is one of the most elegant solutions. That is called, I think it's called a middleman solution. Yeah, I don't know. So I think they OSI standards. OSI data communication. It's a middle layer, right? So what happens is that I don't need to learn 1,000 languages, but I will learn one language, which is called a standard intermediate language, right? And then everybody in the world has to learn that one intermediate language. And if that happens, then you're free to enjoy your sub-universe in your own language. Perfectly fine, no problems. Nobody's telling you not to do that, not to enjoy your own language. But when you want to communicate to someone else, you don't communicate to them in your language, nor in their language, but in this intermediate language. The contact here is that everybody in this world knows this intermediate language, right? So from English to this intermediate language, then this intermediate language can be understood by the other person. They take that and they translate that mentally, maybe even subconsciously, into their own, semantic equivalent. So that way, not everybody does not have to learn 1,000 languages. So and that's a very elegant solution, and we use that in data communication. And that's how all our computers are able to talk to each other today, right? Even though there are multiple different standards, right? How is Microsoft able to talk to I don't know, how many printers are there, right? You talk about Windows. Right? Apple has it a lot easier, right? Because Apple has total control over the hardware. And it can say, well, if you want to connect the printer to my laptop or my computer, you got to talk to it using Appleese only, right? I won't listen. I don't understand anything other than Appleese, right? So Apple has the luxury or the power to do that because that's the only hardware they have. Total. Microsoft, no, they started a long time ago, and I think they went a different route, right? They did a different route. Say we're just going to be open completely, so that we're not going to dictate this is the way. Anybody can make a printer or a device and connect it to this computer, to a Windows computer or a DOS computer. But what we'll do is have you. We have something called a device driver. Okay, a little piece of software that speaks a particular language that is very simple. You can model that in any device that you build, so that can talk to my device driver. And my device driver can translate it into whatever language the rest of my hardware needs, okay? So that is what a device driver is. And that's how, an operating system like Windows is able to handle, hundreds of thousands of different manufacturers and printers, because the onus of me having to understand how these printers operate is lifted off me. Because imagine, right? If I had to say that I'm going to make stuff to which you can, connect your hardware. And then I have to understand how all of your hardware works or talks to me. It's not going to be feasible, right? So maybe I can handle like 10 printers like that, or 10 devices, not more than that. But on the other hand, I say, make any printer you want, make any device you want, as long as it talks in a language that my device driver can understand perfectly fine. So you release the code for that, and then some guy somewhere in Pluto or the Andromeda, galaxy, somewhere, in some device being built elsewhere, all they need is just access to that little bit of information that says this is how we talk to that thing, and they can translate what they need your computer to do into that intermediate language and send it. You can you get that and translate that into it. So that's, and this analogy, this metaphor, as it were, we'll revisit this like 100, 1,000 different times in this course, because this is what we'll be using. This technique, this methodology, we'll use that in many different ways. And I'll point it out to you too when we do that. All right, so it's a data communication, the on and off switches, which you can now do with transistors, right? So when Bell Labs, when they finally invented, I think it was, I'm not so cool. Yeah, I want to say, so sometimes I might say wrong things, and sometimes I might say right things. No, and I have a reason for doing that. And why do I sometimes say wrong things and right things? And the reason is because, and this is very important, I hope all of you enrolled in the class are here right now at this moment, is because my job, as I see it, is not to give you information or give you facts and say, this is what you should do, this is the right thing to do, that's the right thing to do, this is how you handle pointers. That's not my job. Now, there are other instructors, even at Foothill, other colleges, who have a different style, who basically show you the right way to do something, and then tell you, well, do it this way and don't do it that way. Don't do it. So, and because if you do it that way, you'll break. So that's a different style of teaching. That also works for some people. Okay, my style is to say, I'm not going to tell you the right way to do it. Okay, in fact, I want you to discover the right way to do these things. Why? Because unless you discover the right way to do something, it's not your knowledge, right? What do I mean by it's not your knowledge? I don't mean that you don't have the right to use it. I mean that if it's not your knowledge, you probably forget it. You don't have it internalized enough. In order for it to become really a part of you, you have to discover it, right? You have to discover it yourself. You have to go through the pain of discovering it, and the frustration and the struggle. And it's important. Okay, don't curse the struggle. Don't curse your bugs. Don't say, oh, geez. Don't. No, every time you run into one of these stumbling blocks, you have a great opportunity for learning, right? So you say, I'm going to persist through this and get out on the other side, and then see how. I'm glad I suffered. I'm glad I struggled with that bug. I'm glad nobody gave me the answer. Because if someone gave me the answer, I would never have conquered it, right? I would never have come out on the other side. Now, the reason for that is also, twofold. I disagreed with this with other people, even, in terms of bringing up kids also, right? So my philosophy is that, a candle flame, for example, is, I don't know if you can think back to the time in your own life when you first saw a candle flame, right? Now, fortunately, I can remember it. Well, now, maybe not the first time, but I can remember the very first time I was fascinated by a flame, right? So because the flame, if you think about it, is so beautiful, right? Because sometimes you can see through the edges. It's turned blue, and in the middle it's yellow, and right in the middle it's red, and it's dancing. It's dancing all the time. And so I've spent maybe hours as a tiny kid, right, looking at a candle. And I've also tried to touch it. And I'd be surprised if you see a child who has not been warned about the dangers of fire, not to try and touch a flame, right? You take a child, a baby, and expose them to a candle, they're going to try and grab it, right? Because it's so beautiful. And then I want to do it, right? So you want to do it. But obviously, when you touch it, you're going to get burned, you get hurt. Now, there are two schools that diverge at this point. One school of thought says, a parent should not let the child burn itself by touching the flame. It's dangerous, it'll cause a burn and things like that. It should just try to keep them away so that when they're old enough, they'll know that it's dangerous, right? But if you're old and you've never ever touched a flame, never ever seen that hurt or felt that hurt, you don't really have a true idea of what it is. So that's what I feel. And I could be wrong, right? So I feel that it's better for me as a grown-up to not tell the child, don't touch the flame, okay? It'll burn you. Because, what does it mean? It'll burn you. It's never been burned before. So when I say don't, it's going to burn you. Yeah, okay. You might think, oh, burn me. Oh, that must be a really nice piece of candy, right? So it doesn't know what burn means. It never felt it. So for me, I think I like the way in which I just say, that's really beautiful, isn't it? Go ahead and try and find out more about that flame, but I'm going to be right here, okay? So you don't burn yourself completely. You might get a little sting, right? I want to see the child get stung by the flame, not out of malice or not out of, my intent or desire for causing suffering in the child, but because it's control, right? I want to make sure that it's not too bad, but I want the child to feel the flame and get a little bit of a burn, because that way it knows firsthand what a burn is. And then I can talk about it. So, okay, you feel that burn, now you go into a big fire, like, go to the ceramics lab and, open one of those kilns and, when it's not supposed to go. So, you can, that same burn is magnified 1,000 times, right? That the child can relate to. And then, so that's the way I approach programming or anything I teach, really. I don't want to stop you from doing wrong things, right? And in fact, many times, I might even tell you facts that are untrue, right? But not dangerously untrue, but consciously I know that they're untrue, but I will still tell them to you. And why do I do that? And the reason I do that is because I am not trying to explicitly give you information or feed you facts. In fact, I want to make sure that you never, ever take facts from me at face value, right? If I tell you that, it's raining out there, right? Alexa, play rain sounds, right?
Okay, here's rain sounds by
Okay.
Sleep Joy.
Okay, so suppose I tell you it's raining outside, and then you think that, oh my gosh, it must be, Alexa, volume 3. So you might think, oh, Anand said it's raining, so it must be raining out there, right? But you open the curtain, it's not actually raining. It's a nice and fine and sunny day, right? So then you know that I wasn't speaking the truth. But how do you know that? How do you know I wasn't speaking the truth? Because you know for yourself, you've seen it, right? You've seen it, you know that I was not speaking the truth. So in that way, computer science, any knowledge really, when you make the mistake, I tell you both right and wrong, and so that you have an opportunity to hone. Yeah, that's what it is. I think the job of a teacher is not to impart information, but to train your mind to be able to find the information yourself. Okay? How do I train someone to find the information themselves? The best way to train someone to find is just like in machine learning, right? How do you do machine? Well, some of you are. I saw in your introductions you posted notes about saying I want to go into AI and machine learning. That's fantastic. Okay, these are exciting fields. But in machine learning, if you think about it, it's actually super duper simple. It's actually getting simpler because a lot of the learning now happens in an opaque manner inside of the deep net, right? So the distributions are in there. You can't even make sense of the distribution. So you have to come up with really clever and contrived ways to make the internal nodes. Anyway, so where was I going with this? So I need to train the students to be able to distinguish right from wrong. Because once you are able yourself to tell that's right and that's wrong, then my job as a teacher is done. Yeah? Yeah, I don't have to teach you anymore. In fact, I can start working with you as equals. So because now you have the truth in you. See, you can see. You say, hey, you're a dumb guy. talking to me, right? You should don't do it that way. You're going to crash the computer, you're going to melt the screen or something. So you can tell me and things like that. But you can only do that when you've got that sense inside of you. You got a sense of what is right and what is wrong. Well, that works, that doesn't, that, gels, that is coherent, right? And that's not coherent. So you never get that sense. If I keep telling you, this is right, this is right, this is how you do it, this is how you do it. No, I can do that for 15, 20, 30, I can do that for the rest of your life. You're not going to get anything out of it, okay? On the other hand, I could say, well, here is a playground. You can go and play as much as you want. There's all these fantastic structures here, play structures, you do all these things. However, there's also some booby traps here and there. But, don't worry, they're all clearly marked with, red flags. Don't go near the red flags, okay? You go in there and play. And then I keep an eye on you. If you go too near a red flag, I can say, hey, don't, you're going to kill yourself. Come over here, okay? Play here and say. So I can do that. But that way, you'll know, right? You'll know. You can find out. And you know that, and you can also get a good sense of what is right and what is wrong. And sometimes when I say something wrong, you should feel perfectly free to point it out openly in class and say, hey, is that really true? Because I have a account, for example, right? You said it was raining, but here is a live webcam feed, right? And right of Fremont or something like that, right? So there's no rain right there. What do you mean? So I said, yes, I was wrong, totally wrong. Thank you for correcting me, okay? And then I'm very happy to see that. I'm happy because someone took the initiative to think for themselves and said, I'm going to find out. I'm going to find out what the truth is. I'm not going to take Anand's, stuff on face value, right? So I'm going to think for myself and find out. And then when I have a student like that, I feel happy. And you'd be surprised. It only needs one student like that. And then in the past, this has happened, right? One student, initially nobody, volunteers, right? Everybody is in their silo. They're really scared, especially in 2A. Everybody's scared, saying, oh my gosh, it's better to stay silent and be thought that I'm a fool than to open my mouth and confirm it, okay? Or remove all doubt. I think this is Mark Twain said that. It's better to stay silent and be thought a fool than to open your mouth and remove all doubt. So, and CS2A is notorious for that, thing, because everybody is really like the duck feet syndrome, right? Everybody else knows everything. Everybody who's swimming along is doing a lot of work, right? You just don't see it. They're doing a lot of work in their home, especially now. You can't see them, right? But outside, it looks like they're like super brilliant people just swimming along. No, they're doing a lot of work. You can see it. But the problem with that is that these other people who can't do that tend to think badly of themselves, and they don't pipe up and things like that. But once one of you, right, gets that sense, right, or courage to say you're wrong, right? Emperor is naked, right? So once you have that courage to say that's wrong, then you'll be surprised. More people will join you, right? And then it kind of grows exponentially. And before week 7 or week 8, all of you, like how many 70 people in this class? There's 80 people, right? More than that, I think. You're all very vocal. You don't care. You're just talking, open, ask questions, and you also point out camera examples, right? And someone says, this is the way to do it, and you post a note saying, no, I tried that and it didn't work. And those kinds of things will happen. And it's really beautiful, right? The way this.
Just to interject, it looks like on the text, several students have another class to attend.
Oh, yeah,
so
yeah,
I don't know if you wanted to.
Thank you, Andy. Okay, so we're gonna. So we got 3 minutes left. Okay, those of you who have to go to your other class, feel free to switch in about a minute. This is just Zoom, right? You don't have to walk across campus, right? It's just Zoom. Okay, so I got 2 minutes. Let me wrap up. Next class, we'll talk more in detail about data representation. Okay, I'll cover choose complement, floating point, and so on. That concludes data representation this week. Next week, we'll start talking about programming, okay? Now, we want to open a channel, or I don't know if Slack is, Reddit even, or Reddit or Canvas. No, I'll think about it, okay? We want to open a channel for open questions. Meaning that if you have any question that you'd like to be discussed during a lecture, just enter the question there, okay? And if you like, you can just leave it anonymous, or you can sign your name, and then before class starts, I'll look at all those questions. And then, during class, we'll just tackle those questions one after another. I'll reorder or shuffle the questions depending on the sequence of topics we cover in class. But we'll go through the questions that you have. Okay. Now, in addition to that, I also announced our goal for each class, saying, okay, at the end of this class, we'll try and master this particular concept. Okay, we'll try and keep it small, 1 or 2 concepts per class, but we'll do it that way. But we'll open. Until then, maybe one of you can volunteer, collect questions, and email it to me, right? And then I'll talk about those. Next class, we'll talk about data representation, more about that. And then hopefully we'll have better audio visual setup. Maybe I'll also talk to Comcast and see if it's a bandwidth issue, right? It may take a couple of classes too. I don't know, but we'll get there eventually. Okay. So far, is everything working out for you guys? Are you guys enjoying class? Or not too early to ask, but in terms of logistics, are you guys all okay? Assuming the fidelity all improves.
Yeah, everything was great.
All right. If you have any concerns, if you have any problems, concerns, or the way that information is I'm teaching, or if you'd like me to tone down or teach something in a slightly different way, all you need to do is just send me an email. Okay, send me an email. I will absolutely consider it. Okay, I totally consider it. And then as far as digressions go, during class, one of you needs to just pull me back. Okay, because I can't help it. That's right. And you can look at the recordings of my lectures on our nonlinear media YouTube channel too, right? So, I start talking about something and I just veer off, and someone, usually Carol or someone else in the last quarter, they pull me back and say, oh, that's what you're talking about. So please do that. Okay? Help me to help you better. The way I see it is that I know a lot of the stuff, and I really want more people to know this so that we can all enjoy it together. Okay? So that is where I'm coming from. And there's so many cool things we can do, right? Just stick with me, and you'll see that the whole world is your oyster at the end of this course. Okay? So, and the most important thing to keep in mind is for the first 4 weeks, or at least until the drop deadline, okay? Do not give up hope, okay? Many people would think, especially after doing the data representation quiz, no, this is not for me. Don't, okay? Give it more time. Give it more time. In fact, I even have a hypothesis. The longer it takes someone to get into a particular field, the more they get out of it when they conquer that initial bump. Okay, so it is really hard, but when you come out on the other side, you'll think that if you had a choice and said, you want to go back and do the whole thing, except you don't have to do this, right? You'll say, no, I want that struggle, because that struggle is what shaped me, and I really love the way that I've been shaped, right? So I know for a fact that if I'd gone some other way, I would not have this shape. And so you can write it down. You can write it down in your personal journal or mirror, saying, is this bump going to be worth it or not? And then after 5 months, go back to that note that you made and say yes or no. And I bet that if you had struggled in class many times, you would have said, I can't handle this. I'm going to give up. But I didn't, right? I stuck through it. And then you come out on the other side and ask yourself the question. Only if you come out on the other side. Okay, if you die, then you can't ask yourself the question. If you stick around, survive, and come out on the other side, ask yourself the question, was it worth it? Okay? And if the answer is no, I want to hear back. Okay? Just let me know. Right? I came out on the other side, I'm successful, I learned C++, and did all the class, but I don't think it was worth it at all. I absolutely want to know that. Right? Because that's the kind of information that I would use to see what is it that didn't make it worthwhile. And then I'll try and make it more exciting, more interesting, throw in more candy in there. Stuff like that. Okay, thank you so much. Okay, well, I had a great deal of fun, except I got to do something about the lighting and the resolution, and the and the modus, the medium, right? So YouTube or something like that. I hope to see you all on Thursday. Are you guys coming back on Thursday?
Yeah, of course.
Okay.
Thank you for
Yeah,
the lecture.
obviously, we have to.
Thank you. Yeah, usually I ask this question, especially after the first lecture, because after the first lecture, some students are saying, "Okay, that's it. I'm dropping this class." Okay, but I tend to ask this question after many classes, after this class. Okay, even down after in week 5, especially, right? Where you come back is important, because after week 5, many people decide, or week 4, many people decide. But tell me, right? If you want to drop to, I would appreciate it. You don't have to. You're not obliged to. But if you're going to drop the class, just tell me why. It doesn't matter if you say, this teaching style is not for me. That's fine, because if nobody else at Foothill taught in a different way, everybody else was teaching like me, then okay, I'll consider teaching in a different way, right? But now you have options. It's like, you can always say, no, I'm going to go to Dave Harden's class because he teaches in a different way, and that actually works for a lot of people. So that you can. So we have options. You can, so it's not like that. So I have totally enjoyed this class so far, and I'll try and work out a way in which we can do this more effectively starting next class. Okay. All right. Thank you so much for attending today. I hope to see you all on Thursday. Keep the Reddit feed alive. Ask questions. Ask questions here too. On Canvas, right? Send me email if it's any personal or confidential stuff. Everything else on Reddit, just go post information and start tackling questions. Don't worry if you're if it's not working and things like that. Ask questions. Lots of people have been in the same situation as you. That's what I love about Reddit, right? Because in Canvas, every time the quarter starts, it doesn't work. And students think that it doesn't work only for them. Everybody else it works, and for them it doesn't work. And they feel discouraged, right? But I love Reddit because now you can go back in the blue subreddit, you can go back to my previous quarter, the quarter before that. I think we've been doing quests for 2 quarters now, right? The first time I did quests was, I think in 2019. It was last year. We did it last year. And then we used Canvas for the discussion forum. Even though we did quests, we didn't use Canvas. And I didn't like it so much because, a lot of your input in the Canvas forum was very useful. And lots of you guys were saying profound things. And then I was thinking, oh my gosh, these guys are creating such valuable content. And these are posts that you would feel proud about, right? So 10 years from now, maybe you have a life situation that is, making you feel down the dumps, okay? And say, my gosh, my life is totally wasted and I can do anything. No, you can go back to your Reddit posts from 10 years ago, right? And see, no, actually, it wasn't a total waste. Look at this beautiful post I made 10 years ago. And it helped so many people. 15 other students down the line have come thank me for it, okay? I made a difference in the lives of those people. And then you won't feel so much in the dumps anymore, yeah? So keep that in mind as you help. Help everybody, help. And then the thing I like about Reddit is that you can always look at your Reddit feed, go back in time and see that other people have been struggling too, right? You'll see so many individuals, so many students who have been totally, they've been blocked. They don't know what to do. And you'll see them. You'll see them voice their concerns. You'll see them crying on Reddit, right? So I don't know what to do. I'm going to give up. I'm going to, all kinds of things. And all of that is good, right? All of that is good because now if you have a problem, you can read that and say, thank goodness, I'm not the only one, okay? It's like 100 different people who have gone through the same issues as I have. So and they also managed to go all the way to 2C and finish master C++. So you will have that confidence because we're using a persistent medium. Right. Thank you guys. See you on Thursday, okay? Now I need to get to my garden for a few minutes before a meeting, okay? All right, thank you. I'm gonna switch off the Zoom.
Professor?
Yeah.
Do you hold office hour or something? Or
yeah, like I said, check the forum. Not forum. My introductory post, maybe. Office hours are only for discussing confidential and private information, right? About your grades.
Maybe we can freely share our code with you in a private appointment.
Sorry?
Can we share the code with you in a private?
No. You can't share your code with me. Okay?
Okay.
In fact, you should not share your code with your mom or dad, your brother or sister, your friends. No sharing of code. Okay?
Okay.
If you have an issue and it doesn't work, you can always describe your issue in English using pseudocode, right? You can say, this is what I'm trying to do. I'm assigning 5 to X, I'm incrementing X, and so on and so forth. You can say that in English in the forum, and someone will answer your question, right? And if I, or a tutor, or even a fellow student is absolutely curious about why that pseudocode that you wrote didn't work, right? They'll say, can I look at your code, right? Then under those exceptional circumstances, you can send me or the person that requested your code, just that fragment, not the whole program, and say, hey, here's my 15,000 million line program. It's not working. Go figure out what's not working and tell me. Okay? That you find you're very quickly an outcast in computer science, in software engineering. You go nowhere with that attitude, right? So you describe the issue and say, this is the 10 lines of my code that's not working. Not the million lines, the 10 lines that's not working. And that's only when I ask for it, or when a tutor asks for it, else you can do that. But otherwise, please believe this, okay? Give me the benefit of the doubt and believe it for now, okay? Until you finish CS2A. Don't share your code with anyone, your closest relatives, right? No, your boyfriend, girlfriend, nobody's allowed to look at your code. Only you, for now, okay? And let's keep it that way.
Okay, thank you.
Thank you. All right. See you guys on Thursday. Any other questions? We'll have a lot more questions.
I came in late today. I came in late today.
Yeah, okay. We didn't cover. You didn't talk to your classmates. I think we didn't do a great deal of, we're just setting up today. And next class on. From next class onwards, I hope to have a longer question answer time. Okay, at least towards the end. All right. See you guys later.
Thank you.
Bye.
Bye.